Okay, so next topic, we are talking about estimating a population proportion. So some of this is going to continue involving the p-hat that we talked about. Different terminology, maybe. Point estimate, we have this definition. It's just the value of a statistic that estimates the value of a parameter. Those terms, statistic and parameter, we haven't seen them since that first chapter when we had all those definitions. Yeah, that was rough. So remember, statistic applies to a sample. A parameter applies to the whole population. So basically a point estimate is taking some piece of information from your sample and applying it to the entire population. We have done, for instance, the p-hat that we were looking at in the last section. We used that to estimate our population proportion. That was a point estimate because we would take from our sample, 75 out of 150 said they agreed, and we would divide that and use that to estimate something about the entire population. So we have been using these point estimates.
Yeah, I had to go under her.
Miss Williams was supposed to be back today. No, she's gone all week. She's gone all week this week. Okay. In July of 2008, a poll asked 1,783 registered voters nationwide whether they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. Obtain a point estimate for this. So point estimate, that's just the p-hat, like talking about the population proportion. That's the stuff we've done before. So what would I do here?
You take the people that are in favor of it, so like 1,223 over the whole.
And so we get point 629,837. I didn't say how many decimal places. If I asked you to explain this, what would you say?
62.87% were in favor.
Mm-hmm. Is that of the entire population? Right, that's the statistic, so that's of our sample. So if we had a good sample, this could be used to estimate the feelings of the entire population. Okay, so here's a question. Does this mean that most people would favor the death penalty?
But no, because it could have been a bad sample.
Okay. Most people in my sample did. Does that mean that most people overall? It could, but not necessarily. Would a different sample give a different percentage?
Yes.
Absolutely. Every sample is probably going to give us a different number. So we have to be able to ask, how confident are we? And we are leading into this idea of a confidence interval. So we need to be able to assign some kind of interval so we know what range should we expect. So I'm just going to say here, due to variability in samples, we need a range of values. Including the likelihood the interval contains the unknown proportion. In other words, I want to get to the point where I can say, okay, I know that it is probably next to impossible that the entire population also is in favor of this at a rate of 62.9 or whatever percent. But I might be able to say I am 90% confident that the value is between 60 and 66%. So we need to be able to build that range of values along with how confident are we that the true value falls in there. So that leads us into, our next two definitions. We are talking about a confidence interval and a level of confidence. So a confidence interval consists of an interval of numbers based on a point estimate. So based on like that p-hat value. The level of confidence tells us the expected proportion of intervals that will contain the parameter if a large number of samples is obtained. We will use this 1 minus alpha percent notation. So this next slide, you don't necessarily have to write this part down. We are going to talk a lot about confidence intervals. So if I set a 95% confidence level, then what that means, if I made 100 different confidence intervals based on our samples, then we would expect 95 of them to contain the true value. So if I took 100 samples, created this confidence interval for each of the samples, if I was 95% confident, that would mean like 95 out of 100 would contain the true value for the population itself. When we create these confidence intervals, they are going to be of this form. It'll be the point estimate, so like the p-hat thing, plus or minus some margin of error. When I talk about margin of error, it's really just a measure of how accurate the point estimate is. So in other words, we have our point estimate. Which is really just kind of like our guess. It's based on the sample, it's what we think is true. A confidence interval would be a range of values. The bigger the confidence interval, the higher the level of confidence. So in other words, if I drew that interval, that would be lower confidence than this pink one. Which should kind of make sense. The bigger my window, isn't it more likely that my window will catch the true value? You know, if I have a very narrow window, it's not real likely that my true answer is in there. But as I widen that window, then I can be more and more confident that the true answer falls somewhere in that range.
Like having a 50% shot versus like a 10%.
Exactly. Okay. I apologize, today is a lot of writing. Got a few more slides of definitions, and we'll start working actual examples. This margin of error really depends upon three different things. The level of confidence. The more confident you are, the bigger your margin of error has to be. It's also going to be based on our sample size. The larger my sample, then the smaller my margin of error. Okay, if I were trying to guess what percent of the high school liked the lunch option today. If I asked 4 people and 3 of them said yes, and I would think, okay, 75% of the school liked lunch option today. Would I be more accurate if I went out and asked 40 people? Yeah. The bigger your sample, the smaller the error involved. The final piece is standard deviation. We have talked before about how standard deviation impacts it. The more spread out the standard deviation, so the higher the standard deviation, the wider your confidence interval is going to have to be. Because if the original data is really spread out, you're going to have a pretty wide margin of error. So this slide's kind of up to you how much of this you want to write down. Basically, so your margin of error depends on the level of confidence. We kind of talked about in the last one. The higher the level of confidence, the bigger the margin of error. The sample size. As the sample increases, margin of error decreases. And standard deviation. The higher the standard deviation, the bigger the margin of error. This, if you don't write down anything else today, this is important. This is on your formula sheet. So we are actually talking about how to build the confidence interval itself, which is the key thing that we are doing in this section. So to make our confidence interval, this is what you need. These are the formulas. We have a lower and an upper bound. So basically you're going to have your point estimate, your p-hat in the middle. So you're going to do p-hat minus something and p-hat plus something to get your actual value. The 2 criteria for p-hat still have to hold. So n times p times 1 minus p greater than 10. Sample less than 5% of the population. This, I'll let you write that, then I'll talk. If I just ask you for the margin of error, sometimes that is just denoted with a capital E. That's this thing that we're adding and subtracting. So that is z alpha over 2 square root of p-hat 1 minus p-hat over n. You notice we've seen the square root of p-hat times 1 minus p-hat over n. Almost. We've seen it as p times 1 minus p over n, square root of that. What did that represent? That was the standard deviation for the p-hats. So really, we're taking this z value, which is essentially our confidence interval, times the standard deviation. And that gives us our margin of error, which is the amount we add or subtract.
So the margin of error is the
Z times the standard deviation, that whole thing.
Okay. So wait, so what's the alpha thing?
That is the confidence level. So I'm going to show you in just a second when I put one up. It'll be like 95% or something like that. We're going to be reading a probability from our table. Okay, so that's the background. Now we're going to work some examples. I already told you that. So let's look at this. So let's go back to that example we did earlier where we found our p-hat. I want to now create a 90% confidence interval. So on example 1, we found our p-hat. So that is your first step always. And what did we get for our p-hat on example 1?
Oh, it was 0.89 or 6.2.
3.7, is that right? Okay, so we got that just by doing the 1,123 out of the 1780. So that's our point estimate. Okay. Step 2, we need to check the criteria for p-hat. So the criteria, n, what's my n? 1783 times my P, which now I don't know P for the whole population, that's what I'm trying to find. So unlike in the previous ones where they would tell you a P in your problem, we don't know it, so we're going to use the P hat that we are estimating here. Times 1 minus our P hat. That needs to be bigger than 10, so quick check here. Gives me 415.69, which is definitely greater than 10. So that requirement's met. Second requirement, the 1783 has to be less than 5% of the population. Is it? Yeah. We're talking about all registered voters. This would most definitely be less than 5%. So those are the two criteria that we should be checking. Same as before. Okay, step 3. Now we're going to find this Z alpha. Okay. You are going to need your normal table. Now, I want a 90% confidence. So I'm going to draw this little picture just to show you exactly what we're looking for. We want basically 90% to be in the middle. So that means how much would be on each end? 5%, right? That's where the alpha over 2 comes in. So our alpha is really like 1 minus 0.9. So that's 0.1. But you would divide it up over the 2 ends. So it's 0.05. Right? 5% is this piece right here. Okay. Now remember Z alpha notation. This tells you the area to the right. So if 5% is to the right, how much is to the left? 95. You are looking in your table. You are trying to find the Z so that the area inside the table is as close as we can get to 0.95. So try to find the 0.95 inside the table. The closest we can get would be? Yeah, it's exactly in between 0.9495 and 0.9505, isn't it? So what would we use for our Z value? So this is our Z. So that's why I spent all that time doing the Z alpha notation with you, even though it seemed just pointless because we weren't really using it. We need it now. Okay. Now, let's make our confidence interval. So we had to find P hat, check the requirements, find our Z. Now we're going to do our confidence interval. So the lower interval, it's your P hat minus your Z alpha times the square root of P hat 1 minus P hat, running out of space, over our N, which was 1783. So we are just going to put all of this in the calculator. I would appreciate everybody taking the time to plug this in just so we can make sure we can put this in the calculator. Now, if you have that one, the upper limit is pretty easy. What's the only thing that changes? Yeah. So, do I have to rewrite that whole thing, or can I just write plus? If you have it all typed in your calculator already, all you have to do is hit second enter, bring it back up, and go change that minus to a plus. And that gives me 0.649. If I just asked for the margin of error, I didn't, but I could. Do you know what it would be?
We just subtract these two.
Yeah. Well, kind of. They're gonna have to do one other thing to it. Your margin of error is how far these are from our point estimate, our p-value. So you could subtract them, but then you would have to divide that by 2, because if you think you've got the number in the middle, so you want to go above and below that. So you could subtract them and divide by 2. You could look at your p, so this, and subtract one of those. We should get the same. You would either do 0.649 minus your p, or your p minus 0.611. It should be the same number both times. So if I do that, and I kept a lot of decimal places on my original p. We could have done fewer, but we get approximately 0.019 for our margin of error if I had kept my p to 3 decimal places.
That's what you got if you like just subtracted
The margin of error, basically, if you went back and just typed in this thing, that gives you the 0.019. So that's where that came from. Are there any questions here? So, the final thing I just want to do is write a little sentence about what this means. So this would mean, not that it's essentially saying if I went out and collected a bunch of different samples. This was a 90% confidence level. So I would, if I did a lot of samples, then 90% of the samples would contain the true value for my population. So we could say like 90% of all samples. That was what the alpha was in the original problem. It said construct a 90% confidence interval, which is how we decided our alpha.
Oh, like the point.
Mm-hmm. I should maybe even say containing, about instead of p hat, that's a little misleading. How about say containing the true p value? Okay, so we've done a lot of other stuff kind of explaining here, but the main point of this section is creating those confidence intervals, which really the only new piece that we haven't done before, or that maybe we've done but it's been a while, is that z alpha part. That's the trick. The rest of it is plugging things into the formulas, very similar to what we were doing in previous sections. All right, can we look at another? A Gallup poll found 54.9% of those surveyed considered the amount of federal income tax they pay to be fair. Okay, so this is what Gallup said. Results are based on telephone interviews with a random sample of 1,016 national adults, ages 18 or older. For results based on that total sample of national adults, one can say with 95% confidence that the maximum margin of sampling error is 4 percentage points. So if I wanted to create a confidence interval for this, that's what they're asking me to do. My p-hat, what was their final percent that they went with? Okay, so my p-hat is 0.549. To get your confidence interval, you add and subtract the margin of error. What was my margin of error? 0.04. So basically, if I subtract 0.04, we get 0.509. If we add 0.04, we get 0.589. So this is the confidence interval. Okay, in other words, we are 95% confident. The true proportion, or P, lies between those values. Okay, and the 95 is because it told us in the problem this was a 95% confidence. I want to do one more, creating the full confidence interval. And that may be as far as we get today. We'll see how much time we have left after that. Alright, a survey asked 800 16 to 17-year-olds in the U.S. if they have ever used their cell phone to text while driving. Of these, 272 indicated that they have attained a 95% confidence interval. Okay, so step one. P-hat. How will I calculate p-hat? Step two, we have to check the criteria, make sure we can do the p-hat stuff. So my n is 800, p-hat 0.34, 1 minus p-hat. And I get 179.52, which is most definitely greater than 10. If I'm talking about, would 800 be less than 5% of all 16, 17-year-olds? Yeah. Okay, so that requirement is met. Step 3. We need to figure out our Z alpha over 2. Okay, so 95% confidence interval. That means 95% falls in the middle. So how much is left for the ends?
So it's 5.
95% in the middle. So there's 5 total divided by 2, and each one gets 2.5%. Okay. So that means we just go with the positive one. So if this is 2.5%, remember the table gives you area to the left. So how much area is to the left? So you are looking inside your normal table, finding the 0.975 inside and then telling me the z value that's associated with it.
1.96.
Alright. Everybody know how to find that?
But we're looking for 0.975.
Yes.
This one that says it exactly, huh?
So then, step 4 is the confidence level. So, your confidence interval is basically your p-hat. Can I just write it as plus and minus so I'm confusing them? Your z times the square root of p-hat 1 minus p-hat over n. So I'll do the minus one first. And you can just do second enter and change it to a plus. If I want my margin of error, there are like 3 ways you can calculate it. You could do your p-hat, subtract that value. You could just calculate the 1.96 times the square root. You could subtract those things, divide by 2, any of those options. So, what is my margin of error? Yeah, 0.0. Well, depending on how many decimal places used in your confidence interval. 0.03. So basically, that's the amount we're adding and subtracting each time. So finally, let's just write a sentence. This was a 95% confidence level, so 95% confident. The true proportion is between 0.307 and 0.37. I will finish the notes. You're not going to have a full class period to work. I've got a few things left to talk about, but we'll finish the notes tomorrow. So this is the assignment. It will be due, today's Tuesday, so it'll be due on Thursday. Okay, so this is the whole assignment from the section. I would get started, do a few of them, and that way if you do get stuck or anything, you can ask